Welcome to lesson 715. Today we're looking at equivalent fractions and reducing fractions. So a little fractional work. If you hear some noise in the background, it's probably my children. I'll be honest. They are here. They're not being as quiet as I want, and I apologize if they are distracting you. But let's go ahead and get into this. These concepts are new. No, they're not. They are definitely a review. But we're going to cover a number of different things. So as we look at equivalent fractions, right? Equivalent fractions can really be looking at what a fraction is, right? We have a n for numerator, we have a d for denominator, and with equivalent fractions have different numerators and different denominators, but overall they have the same amount or same percentage of area shaded in a circle. So for example, you have the 1/4, right? And the picture right there of the 1/4. And then you have the 2/8, which when you shade it like that looks like that. And then you have the 4/16, which looks like that. And of course the same amount of area is shaded in. So what that's really saying is that all three of these fractions are equal to each other or equivalent to each other. And we could definitely take time to figure out why they are, and this also gets into the idea of reducing fractions, which is another concept we're going to look at today. Equivalent fractions, right? How does this idea work, right? When it comes to equivalent fractions, we can use this concept to, one, create common denominators. Very, very useful technique, as we'll get into adding, subtracting, fractions in a few lessons, so we're going to need that. We're going to do a little bit of adding today, though that's not necessarily going to be the emphasis of the entire lesson. Right? We start with this, right? Write a fraction equivalent to 1/3 that has a denominator of 6. So I want 1/3 to equal something over 6. So how does 3 become 6? Right? I would multiply by 2. So if I multiply by 2 on the top, in essence, right? I'll write it down here. If I'm multiplying by 2 over 2, this is equal to 1. So I'm really multiplying by 1. And so it's staying equal. And so in the end, I get a fraction of 2/6. Right? Next, write a fraction equal to 1/2 that has a denominator of 6. So that's 1/2. That's not a 2. 1/2. And it's going to equal something over 6. Right? How does 2 become 6? That's kind of a no-brainer because we just did the same thing over here. But we're just going to reverse it a little bit. So we're going to multiply by 3 on both sides. And maybe as you're looking at it, you're like, I know that it's 3/6. I don't even have to show my work on that part. Great. I'm glad that your brain works that way. But now we have 2/6 and 3/6. And because we have common denominators, we can add these fractions together, which are going to equal 5/6. And so finding equivalent fractions is very, very useful when it comes to adding fractions. And so we have that concept. Right? We're going to also do some reducing fractions, right? That's our second major concept here. Now up on the board you see I have 3 of the exact same fraction up here, and you're like, why? Right? Because when it comes to reducing fractions, there's a couple different things that we can look at here. The key thing to reduce a fraction, to take it into lowest terms, is all about factors. Right? Finding a factor that we can take out of both of them. Right? And so as I look at the 12 and I look at the 18, I know they're both even numbers, so I could start by dividing both of them by 2. And so I'm going to come away with this concept. Now the question is it in lowest terms? 6, 9, no. They can be reduced again. And so I take these steps, and now I have 2 over 3. And now I've gotten to lowest terms, right? Another way I could look at this is I could say, okay, 12 and 18, maybe the first number that came to your mind wasn't a 2, it was the 3. You recognized the relationship between them. So you said, okay, 12 divided by 3 is 4, and 18 divided by 3 is 6. But now you recognize that they're both even numbers. And so we reduce again, and once again get to 2/3. Right? So why do I have this third fraction up here? The key idea to get to lowest terms is factors, right? And in particular, we would say common factors. And these first two processes are getting us there. Though you can see it's taking not just one step, but it's taking multiple steps, right? We got step 1, then we got step 2, and then finally we come away with an answer. However, if we want to get there in one step, which sometimes it's very easy to recognize and do it in one step, sometimes it's not as easy, right? But the key to doing a one-step fraction reducing is all about the GCF, or the greatest common factor. And as we're looking at these two problems, we can really find the greatest common factor by understanding the parts that we've been taking out. We've been taking out a 2, we've been taking out a 3, we've been taking out a 2, taking out a 3, right? 3 and then a 2. So 2 times 3 is actually 6. And so if we were to take out, using the greatest common factor now, which in this case happens to be 6, we would get our final answer of 2/3 in one step rather than 2 steps. Right? Now, if your brain works like this, if you recognize it, use the greatest common factor. It makes it a little bit faster, right? But if your brain doesn't recognize it, then use these concepts. Use your divisibility rules to help you break down numbers. If you recognize they're both evens, yeah, take out that 2. If you see the 3 first here, yeah, take that 3 out first, right? In the end, as you continually look and analyze, you'll get to your lowest terms. All right. Then, the book throws a couple other different ideas at you. It's going to throw some mixed numbers at you and making sure you reduce those fractions also. So let's take this one last example. It says write 12 over 9 as a mixed number first with the fraction reduced. Right? So how do we create a mixed number? So I'd have 12 ninths, right? This is literally 12 divided by 9. So how many 9s go into 12? Right? That looks like this. That's how we're really speaking about this. And so we would say, okay, 1 9 goes into 12, and you're going to get 3 ninths left over, because 12 minus 9 equals 3. But 3 ninths, of course, is not a reduced fraction, and we can take a 3 out of both of those and get a final answer of 1/3 for the fraction. And so in the end, we get a final answer of 1 and 1/3 for our mixed number with a fraction reduced, which is what we would want for a final answer. Okay, then I'm giving you 2 sample problems to work through as you look at this idea of 1, equivalent fractions, and 2, reducing fractions, which in the end, as you have seen, they really work together. That's it for lesson 7.15.